Hello, and thank you for joining us today for Frost&Sullivan's latest webinar. Today's event is titled Fluid Power 4.0, Smart Industrial Internet of Things. Enabled fluid power solutions create new business models and investment opportunities. My name is Anna, and I oversee Frost&Sullivan's Growth, Innovation, and Leadership briefings. Today's presenter is Varun Raman, Research Analyst here for our Industrial Automation and Process Control practice at Frost&Sullivan. His biography can be viewed on your screen at this time. He has a deep understanding of the digital transformation and technology convergence, and he also has expertise in the fluid power equipment and system integrators in developing growth strategies. You can follow him on his LinkedIn page. And with that, I would now like to hand the presentation over to Varun. Please begin.
Thank you, Anna. Good morning, good afternoon, good evening to our various viewers who are here for the Frost&Sullivan briefing on, Fluid Power 4.0, specifically where the premise of this webinar is to detail the impact of the industrial Internet of Things on the fluid power industry and how, the IIoT is expected to ensure the survival of the fluid power industry against increasing encroachment from electric drives. So as Anna mentioned, I'm Varun, and I'm the research analyst who's been working in the fluid power domain here at Frost&Sullivan. And if we look at today's focus points, we're going to be talking first of all about the state of the industry, and then we're also going to be focusing on digital transformation. We're going to be looking at the services landscape and how some of the digital services are being offered specifically for fluid power equipment, and what are the implications that these would have on manufacturers of fluid power equipment, system integrators who use various different types of fluid power equipment to build machines for the end users. And finally, we're also going to be looking at the implications for the end users themselves. And then we'll also talk about the customer journey, where we'll be discussing a few customer success stories on how implementation of IIoT concepts has brought them success in their respective domain. So moving forward to the state of the industry, based on Frost&Sullivan's extensive market analysis, we currently see that the total fluid power equipment market is currently worth $52.67 billion. This is for 2018. And if we look at how this market size is split across the various regions, we see that Europe, Middle East, and Africa is the largest region, accounting for over 40% of the global revenue, followed by North America, which accounts for a little under 30% of the global revenue. We also see that Asia Pacific accounts for a little under a quarter of the global revenue, with the remaining 6% being accounted for by Latin America. And we also see that within fluid power, we have hydraulics and pneumatics, and the split between these two is heavily in favor of hydraulics, with more than 3/4 of the fluid power revenue being attributed to hydraulics and about 23% being attributed to pneumatics. In terms of the growth trajectory for these respective markets, if you think of them as separate markets, we see that pneumatics has much stronger growth going forward, especially in Asia Pacific and North America, and this is going to result in a slight tilt towards pneumatics. Maybe not too much, but maybe from 23% to, in the next 5 years, we can see that number going up to maybe 25 or 26%. But hydraulics is still going to account for more than 3/4 of, or nearly 3/4 of the global market. And if we look at the competitive landscape for fluid power equipment in terms of the top 5 manufacturers of fluid power equipment, we see that it's quite competitive at the top, with Bosch Rexroth and Parker Hannifin having very close market shares, 11.7% for Bosch Rexroth and 11.5% for Parker Hannifin. And then we have SMC Corporation, who's a manufacturer of pneumatic equipment, in third place with over 6.5%. And then we have Eaton Corporation with 5% market share, and then Festo very close behind with 4.9% market share. SMC and Festo, as you may know, are purely pneumatic equipment manufacturers. Parker Hannifin Corporation offers the full spectrum of fluid power equipment, catering to pneumatics, mobile hydraulics, as well as industrial hydraulics. And then you have Bosch Rexroth and Eaton Corporation, who are predominantly hydraulic equipment suppliers. And then moving forward, we also, some of the major challenges and trends that we see in this industry. So the biggest challenge for fluid power domain as a whole is the electrification of fluid power applications. So this has great ramifications in terms of the applications that are being catered to currently by fluid power equipment. While fluid power is very effective in terms of offering high power density, particularly in the case of hydraulics and in the case of pneumatics for some types of factory automation equipment, there is a tendency for a lot of end users to migrate towards electric technology, and this has also been encouraged to some extent by the system integrators, because they see electric solutions as a cleaner solution. So with fluid power, often the biggest challenges in dealing with fluid leaks, so oil in the case of hydraulics and air in the case of pneumatics. Both of these have energy efficiency ramifications, so electrification is seen as a way to counter that, to offer a much cleaner solution. And then specifically if you look at factory equipment, the faster changeovers, more flexibility that some end users demand these days are better catered to by electric solutions. But then there is also the other fact, which is electric solutions often tend to be more expensive compared to fluid power solutions. But then, if we look at the number of greenfield opportunities, they're almost predominantly being catered to by electric solutions, whereas fluid power still continues to, have its advantages in brownfield facilities, where the cost of conversion plays a role in slowing down some of this electrification. So brownfield facilities are also where IIoT has the greatest potential, primarily because of the fact that it can help improve existing processes and help reduce operating costs. So then we have the other challenge for fluid power equipment, which is shortage of skilled workers. So this is something that you can see in a number of manufacturing industries. Particularly in the case of fluid power, we see that the retirement of baby boomers, who are predominantly working in the fluid power industry. So their retirement has not been, addressed by the fluid power equipment manufacturers, primarily because, young graduates are not seeing fluid power as a very attractive industry. There isn't the same pull that you have with fluid power that some of the other industries, perhaps like semiconductors and more electrified mechatronics industries possess. So that is an issue that is it's a global issue, so it's not limited to any particular region. And this shortage also has the effect of it has an effect on the innovative solutions that are being produced by fluid power equipment manufacturers. So the fact that we can have more skilled workers who have a broad range of skills, particularly digital skills, which are in high demand these days. So with more digital skills, they are looking at coming up with more digital and more innovative solutions. So until that shortage has been addressed to a reasonable extent, this is going to still remain a major challenge for the fluid power industry. And then we also have price war and penetration of low-cost fluid power equipment. Penetration of low-cost fluid power equipment has been encouraged to an extent because of the fact that fluid power equipment can be thought of as commoditized products. So often when it comes to the differentiating factors among different manufacturers, cost is often the major differentiating factor, especially when from an OEM standpoint. And OEMs and distributors tend to go with the stock up with the equipment that offers the best cost economics for them. often at the cost of quality. So this strains the margins for some of the fluid power equipment manufacturers because the prices of raw materials have been going up. And so that puts a strain, and then you have low-cost fluid power equipment coming in from other regions with lower manufacturing costs. So the bigger manufacturers are also forced to compete on price and lower their uh, products, and they lower the price of their products. So this is a considerable challenge that has yet to be completely addressed. And then if we look at the trends though, greater electronic integration of fluid power equipment. So this ties in directly to the electrification, where this is seen as the counter to that challenge, particularly for brownfield facilities where some of the aging equipment needs to be replaced. Going with fluid power equipment that has greater electronic integration, therefore better connectivity, more intelligence built directly into the components such as your valves, actuators, pumps, and so on. That helps with getting more data. That helps, uh, you know, with more data. It can also enable analytics, and then you also have a chance to improve your system efficiency. Because that is one of that's the biggest Achilles heel for fluid power, is its energy efficiency compared to electric technologies. So this is a trend that's been happening for a while, but it's going to continue. It's going to accelerate in the future. And then we see hydraulic hybridization of machines. So this one is quite specific to hydraulics, particularly mobile hydraulics, where in the case of off-highway vehicles, of their some of the off-highway vehicle manufacturers are expected to follow the example of the automotive industry, and where they're looking to increase the number of hybrid vehicles that they sell every year. So mainly driven by emissions regulations, but some of the challenges in that area, remain the fact that electric hybrids, from an infrastructure standpoint, the infrastructure to support electric hybrids does not entirely exist in the case of off-highway vehicles, because they often tend to work in remote locations. And then, battery technology has also not developed or evolved to the point where they can sustainably power these heavy machines for a long time. So until that can happen, emissions regulations are not going away. So off-highway vehicle manufacturers still need to find solutions to these challenges. And hydraulic hybridization is something that's come up recently, and it's expected to accelerate over the next few years. So with the use of accumulators as a sort of battery to store hydraulic energy and release it when required, that is proven in a lot of cases to improve fuel economy by 10%, 15% in some cases. So that is a big improvement, and so we're going to see more manufacturers follow that. And then we also see component level IIoT implementation. So when IIoT first came up, there was a lot of talk where some of the biggest end users, the biggest competitors, manufacturers in every field, take it food and beverage, food and beverage, and automotive industry, and all these major end user industries, they went with a enterprise level IIoT implementation. Now that might work for the largest manufacturers who have multiple manufacturing facilities across multiple countries, and so for their scale, an enterprise level IoT solution would work. But that solution may not necessarily work for every single end user across the lower tiers. So tier 2 and tier 3 end users would not be seen as early adopters of IoT technology, primarily because of the fact that they didn't want to implement expensive enterprise-level IoT solutions. But we are seeing a pickup in the number of component-level IoT solutions that are being offered, where some of the analytics and IoT-related concepts are being implemented at the product level, at the component level. So you have intelligence built into pneumatic valves, into hydraulic pumps, so that all the necessary information and necessary improvement that is being done to that particular component. So that is something that is starting to pick up across a number of end user industries, and this is also expected to get more people on board in the whole IoT movement, particularly because they can then start to see the improvements that they can get from one component, and then that acts as a pilot trial and validation of the proof of concept, which they can then extend to other systems and then across other manufacturing facilities that they may have. So moving forward, we have when you come to digital transformation. So this is the digital transformation roadmap that Frost and Sullivan sees for IIoT, especially with fluid power. So starting with Industry 4.0 IIoT, we're talking about digitalization. So digitalization talks about the digital transformation happening across a number of end markets. And this is, this also encompasses the set of technologies that enable, drive, and accelerate digital transformation, thereby creating more businesses and more business opportunities across, the value chain. The Industrial Internet of Things and some of its associated concepts such as big data, data analytics, cloud solutions, mobility, cybersecurity, cognitive computing. So the Industrial Internet of Things is the most impactful of them all. And then we also have artificial intelligence and machine learning. So machine learning can be thought of as a subset of artificial intelligence where systems have the ability to automatically learn and improve from experience without being explicitly programmed. By leveraging the machine data and combining with existing enterprise data, a new generation of applications can be enabled that are able to analyze, acquire insights from large volumes of multi-structured machine data, and then take action on their own. So with more data being made available and improvement in the prediction abilities of these systems, results are going to improve. Then we have smart telematics and digital platforms. So telematics is something that is already being implemented across mobile hydraulics, particularly in the off-highway vehicle sector, which is among the biggest end users for mobile hydraulics. So we have legislation where electronic devices are installed on every vehicle to enable GPS tracking, geolocation, and other factors. So by introducing intelligence into the system, with smart telematics, we are now going to move into a scenario where maintenance is not going to be driven purely by manufacturer recommendations, but maintenance is going to be driven by the data that we're collecting. So instead of changing oil or doing any maintenance for based on the number of operating hours, it's going to be determined by the actual machine condition. So this is an area where, especially for fleet managers, companies that operate fleets of off-highway equipment, this is going to be a game changer. And then we have digital platforms. In the case of digital platforms, organizations are integrating and applying digital technologies to create fundamental changes at all levels of business operations. So by leveraging the latest technologies, businesses can achieve greater success, drive innovation, and gain a competitive advantage. So digital platforms is not just a way to improve their business, but also to acquire a differentiation compared to their competitors. And this we can see across all industries, particularly where the internal and customer-facing processes need to be streamlined for smoother operation. Then we have the second transformative force, which is shift from CAPEX to OPEX. So this is particularly true for IT and software, where companies who are already having a strain because of significant IT budgets. And so this is the way where some of their core competencies are in business. And so they're starting to look at which aspects that they can do themselves and which aspects can be outsourced to someone else. And then, by moving to an OPEX model where it's a service-driven economy, they're looking to cut down on their outright capital expenditures, but then, shift it to an OPEX model where they are, shelling out the amount every year. I know it's like an annual subscription, but they still get the services. So this presents a win-win scenario for both the service providers as well as the end users. Then we look at the third transformative force, which is the movement from layer to network architecture. So initially, we had a number of solutions that were primarily proprietary solutions. So there is a movement towards adopting open standards, particularly so that interoperability of equipment is no longer an issue. Then we also have adaptive OT cybersecurity. So cybersecurity obviously is one of the biggest factors, and in fact one of the major stumbling points when it comes to IoT adoption. So with increase in cybersecurity and better security, making sure that preventing cyber attacks, that's one of the major forces that are driving IoT. Then we have digital threads and edge analytics. So in the case of edge analytics, we see that these edge, like I said, this ties into the component level implementation, where the edge analytics is being done at the component level itself rather than at an enterprise level. So that is one. That is the third transformative force. Then the fourth transformative force we see are new business models. So with the way IoT is transforming everything, so many different digital technologies coming in, technology convergence and all that. Even the way business is being done has to, adapt, with the new way of thinking. So some of the emerging business models we see there is a shift from purely fixed product-driven business to more services-driven and also outcome-driven business models. So this is something that is happening across a number of industries, and we see that having a great effect over here as well, and we see that having implications for how fluid power service is going to evolve over the next 5 to 10 years. Then we have the fifth transformative force, which is factories of the future. So this is one of the biggest transformative forces that everybody is talking about. We see cognitive factories, where with manufacturing entering its fourth revolution. So with Industry 4.0, which is the buzzword on everybody's lips, we see cognitive factories, machine protocol landscapes. So everything is turning digital, everything is becoming smart. Collaborative robots, where humans and robots are working in tandem with each other. So it's not a case of robots replacing machine workers, but rather supporting human workers. And then we have augmented reality, which we expect to see. We expect a lot of traction to happen over there in the future, particularly in terms of maintenance, where this is going to help simplify maintenance. It's going to help augment the revenue streams of service providers. And then you have smart servicing, which is going to be data-driven servicing. So this ties in with the smart telematics as well, but more on a factory level. And then we have the sixth transformative force, which is the shift from site functional excellences to enterprise scale rollouts or multi-scale rollouts. So with IoT picking up, we see that with more component level implementation, that is going to then go across multiple components being IoT-enabled at the factory level, and then multiple systems being IoT-enabled at the factory level, and then eventually with the benefits that each these factories are going to be bringing year on year. We expect this project to then be extended to other factories across, and the revenue, the increased revenue that end users are expected to see over the years, the increased cash flow that they can reap from the reduction in operating costs over the years. So that is something that is eventually going to transform the whole landscape here. And then we talk about traditional troubleshooting. In terms of the factory maintenance, especially in the case of pneumatics, hydraulics, the biggest challenges that a lot of end users report include the fact that maintenance is expensive, resource intensive, and complex. So in particular, when we talk about troubleshooting, so if we take the example of pneumatic equipment, the biggest expense in the case of pneumatic systems is the electricity cost from running the compressors. And in the case, in case there's an air leak in the system, troubleshooting for the source of that air leak is often a very expensive process because a lot of manufacturing plants tends to have hundreds, even 500s of valves, and so trying to triangulate the source of that air leak is not just expensive, but a resource-intensive process. You're going to have maintenance personnel looking at every single valve in the factory. and then trying to identify the source of that leak. And so this also complicates maintenance. And then this also results in a scenario where sometimes, the wrong valve is replaced. We've heard situations where, despite constant replacements, sometimes the problem is not solved because there is some other issue which is central to why the air is leaking in the first place. Some of the ways end users have, resorted to this is to have annual air audits, where every year, they go through a complete check of their airlines using laser technologies and everything. But this, is not a foolproof process, and often, while in some cases it might bring benefits, it's not the best way to troubleshoot. So in this case, we see digital technologies playing a major role. So we have, you have dashboards, you have the cloud systems, you have AI, machine learning, you have sensors, you have connected devices, temperature sensors, and then you have wireless technology. So all of this, when enabled, can, do the same job of troubleshooting in a much, much faster manner than the traditional methods. So in the case of the same example where you have hundreds of valves operating in a factory environment. So, there are various sensors attached to each pneumatic valve that are constantly measuring the airflow and other various parameters of the valves. And then, when leak is detected in any particular valve, that is immediately flagged, and the maintenance personnel can immediately look at that and then attend to that, and then fix the problem, either by fixing the leak itself or by changing the valve, whichever is the solution at the time. But so data-driven troubleshooting saves time, it saves expense, it saves effort, and with energy efficiency being the biggest problem for fluid power systems, the amount of energy consumption that the energy savings that each plant has reported by using digital technologies and smart pneumatic systems. It's an improvement of at least 20-30% in a lot of cases, which especially in North America, where you have the Better Plants program, where the Department of Energy, gives out incentives, and plants are being awarded and rewarded for their efforts in reducing energy consumption and improving CO2 emissions. So this is something that can help in this scenario. And this is also applicable to hydraulics, where in not just on a factory level, but if you look at mobile hydraulics, the various sensors and everything, it can help identify the source of the problems much quicker. Not just in terms of leaks, but also in terms of the condition of the components themselves. So predicting failure, seems to be the biggest driver for adoption of digital technologies. And then we have the first poll question. Over to you, Anna.
Thank you, Varun. Audience, I have just pushed out our first poll question, which is, what stage is your organization with respect to IIoT implementation? So we'll leave this open, and if you can take a moment to select your answer, and we'll reveal the results at the end of the session. Over to you, Varun.
Thank you, Anna. So moving forward, we have digital services where we're going to be talking about the services landscape. So the services transformation slide. So this is a typical example of how the services landscape is in the fluid power industry. So we have the, let's say, OEM, the manufacturer of the fluid power equipment. And then that is often sold to the customer through a distributor. And then whenever there is a service request that comes in, it usually goes to the distributor. And then depending on the nature of the service request, the distributor decides whether to perform the service themselves or to involve the manufacturer. And this process is not only time consuming because they have to identify the issue, understand it, and then decide whether to involve the original equipment manufacturer. but then it's also not necessary that the problem itself can be fixed quickly, and then service, and then there are service contracts, and then so this is often not a simple process. It's not necessarily an inexpensive process as well. Where the where digital technologies can help over here is the fact that you have all your assets at the machines on your factory level, or even your mobile machines, where you have all the assets connected. So those are constantly collecting data. So there's a mountain of data that is being generated on a daily basis, which is also then pushed through cloud storage through a gateway, where these are constantly being analyzed by AI and machine learning programs. So with analytics, it is possible for a service request to only be placed when it is absolutely necessary. So this way, service is no longer driven just by the distributor, but then is driven by the analytics. So data-driven analytics is going to transform the way the services industry operates, particularly for fluid power equipment, and the installed base of sensors and other connected assets are constantly going up. So the digital coverage is also increasing, and this is going to be of great benefit to end users, particularly because they can vastly simplify their maintenance. They can time it perfectly, so that with advanced knowledge of when their machine might fail, they can time them shutdowns in such a way that they have minimal downtime, and then that also helps improve their bottom line. It helps improve their reduce their operating costs, and then also with proper servicing, it's the machines are always in good condition, and sometimes that also helps them improve their productivity. This way, their products acquire a good reputation in the market. It helps augment their revenues. So, there's so many advantages that can be taken out of the digital transformation of the services landscape. So this is something that Frost&Sullivan is, looking at, and also this is an area where we can help, particularly because of our expertise in talking to both the OEMs, the distributors, as well as the end users, so that we have all perspectives, and we can sort of bridge the gap between all three of them. And then we look at the evolution of business models. So we have three business models outlined here on the slide. So we have a products-driven model, a services-driven model, and then an outcome-driven model. So in the case of the products-driven model, so we see that the standard products are often commoditized products, and then so the pricing in this case is target-driven. So this is purely a capex model, where some service is done either by the distributor, or it could be done by the manufacturer themselves in the case of a custom product. But then the maintenance is purely reactive based on when the end user requires maintenance, and so the differentiation here for this model is simply boils down to the quality of product. So the focus here is not on the service, but on the product itself. In the case of the services-driven model, we have the offering where it's a product combined with the customized service, and then the response is simultaneous over-the-air updates. So the service provider or the manufacturer who's providing the service, follows up constantly with the end user, in order to determine service needs. Pricing is based on the customer's KPIs, and so this is not a capex model, but more of an opex model, where the services are designed to ensure that the product continues to function, to the best it can, to prolong asset life. And then the main differentiating factor over here is customer experience, where the maintenance itself is preventive, so it's done on time. Sometimes maintenance, the slight disadvantage over here is that if the assets are not completely connected, they could be doing maintenance much earlier than actually required. Whereas if they're using data to dictate their service needs, then that's a more accurate way of servicing the machines based on the requirement. And then we have the outcome-based solutions where the offering is actually a personalized value. So it's not to do with the product or the service itself, but rather the outcome, where the pricing itself is outcome driven. So the contracts dictate that the service provider gets paid depending on the nature of the outcome. So whenever the particular outcome is reached, or whenever a particular goal is reached, that's when the amount is released to the service provider. So this is an OPEX or a profit sharing model where specific outcomes can create can drive profit margins, and then from this profit margin you have the amount that's shared with the service provider. In this case, the maintenance is proactive because the outcome dictates that the service provider has to achieve a certain outcome, whether it is an improvement in asset life, whether it is reduction in system energy consumption by 10%, or whatever is the outcome dictated in the contract. Everything is done based on the best available products that they have. They have to capture a lot of data, and so the differentiation over here is the outcome on what is the outcome that needs to be achieved. So at the moment, most of the business models being adopted by customers in this industry tend to be a mix of product driven and some are services driven. But then we are starting to see a bit of a movement towards outcome driven models, particularly where people are interested in reducing the cost of hardware itself and are okay with paying a recurring subscription fee for software as long as they are achieving their outcomes. So that tends to be a win-win for both the service provider as well as the end user. And so if you look at the implications that this has across the value chain, so for the manufacturers, it is a chance for them to push through their digital components. So where their components themselves have a good amount of electronic integration and a lot of digital services or digital applications built in to the product itself. And this helps, with product and service differentiation, which helps them stand out from some of their competitors, particularly as this is a very competitive market and, where often people compete on price. So this is a good way to distinguish themselves, and, it also helps them charge a premium for certain products. In the case of the OEM system integrators, people who build complete systems or machine builders, the OPEX model particularly has the advantage of bringing with it a recurring subscription fee. So with the cost of hardware dropping, for sensors and other peripherals that are being used to enable IoT solutions, people are focusing on the software, on the power of data, to monetize data, in order to use analytics to dictate their maintenance needs. So the recurring subscription fee helps augment revenue streams for the system integrators, and it also helps them offer greater customer value. In the case of end users, who are the users of fluid power equipment, analytics-driven maintenance as opposed to preventative maintenance or a fixed schedule maintenance vastly plays a role in keeping asset downtime to a minimum. So they are able to run their machines longer, they're able to run their machines better, and then also they're able to plan their maintenance shutdowns better. So this helps reduce operating costs, this helps improve their productivity, and then with it they can also have a total overhaul of plant operations as they start to extend these technologies to more systems and more assembly lines across a manufacturing plant. So these are some of the biggest implications that we have across this value chain. And then over to you, Anna, for the next poll question.
Thank you, Varun. Our second poll question is, what are the biggest challenges you face in developing and delivering digital solutions? So we'll leave this open, and back to you, Varun. Okay, over to you, Varun. Thank you.
Thank you, Anna. So moving forward, we have the customer journey. So we're going to be talking about the customer segmentation and also some of the customer success stories that we have seen. So we primarily segment the customers into non-digitizers, selective digitizers, and enterprise digitizers. So non-digitizers are the companies that are, they have not yet adopted IoT solutions, mainly because some of the challenges include the cost of modernization, so they might not be a big enough player in their respective field in order to be able to, justify the cost part of things, and so they would not be able to be able to spend that money on that. And then also this also has to do with capital availability. They might not be able to invest in these technologies, or they might be running outdated systems. So IT and OT integration remains a very big challenge. So for these customers, key focus areas, number one is to shift from paper-based operations to digital operations. So with the implementation of more ERP, CRM systems and other digital systems, they're going to have to first look at their supply chain, and also from then focus on critical areas and assets for digitization. So, if they want to get on the IoT movement and start to see what is the big difference that they can get from, adopting IoT solutions, then, they're going to have to focus on the most critical areas, the most critical assets where they would want to get the most amount of data, where they would want to drive the biggest improvements in the way that machine operates, in the way energy consumption is reduced, productivity, and all the other benefits that they want to see from IoT. So that is going to be also that helps act as a pilot project, so that the benefits that they can see from that can then be extended to other assets across their plant. And then obviously we have affordable digital innovations. That's going to be their key focus area, where not just about getting a critical asset looked at, but also how they can do it in an affordable and a cost-effective way. Then we have the selective digitizers, who are companies that are adopting some level of IoT concepts. They have some IoT implementation already going in their respective factories and manufacturing locations. So for them, the biggest challenges would be siloed value chain. So they have digital implementations, but then they have digital silos. So they're operating, each department is operating separately, so there isn't a wholesome integration yet that can then drive a bigger change in terms of the way they operate. Change management still remains a challenge, where certain departments are very open to new technologies, whereas some departments are very conservative. So in terms of breaking through that conservative mentality and bringing about a change in the way the company operates, so that remains a challenge. And then there is lack of enterprise-wide visibility. So this could be where they might have multiple manufacturing facilities, but then they have a difference in mentality across the different plants, so that some plants are more digitally savvy compared to some of the other manufacturing locations that they have. So for them, the key focus areas would be to first break these digital silos, so that they have a company-wide policy in terms of IoT, and they are able to get on board completely with the whole digitalization of their manufacturing facilities. Moving to hybrid models, so it's not just looking at product-driven or service-driven models, but looking at a combination of these business models, where there might be certain business cases where one business model would work, and other business cases where other business models would be better for them. So it's about evaluating those business cases and doing justifying the cost economics. And also another key focus area, particularly in the case of the component themselves, so would be to improve valve or actuator geometry. So this is something that we hear a lot from companies that are adopting some level of IoT solutions, because they're starting to see some of the benefits. They are looking at how they can improve the geometry of the valves and actuators, thereby improving the flow, thereby changing the way the valves operate, thereby reducing energy consumption. And then this is also an area where additive manufacturing comes into play. A lot of companies are starting to tinker with additive manufacturing technologies, so that they can get valves and actuators with geometries that you could not possibly get with traditionally machined products. So this is another area that some companies are focusing on. And then we have the enterprise digitizers, who are the large companies who have adopted enterprise-wide IoT solutions. So they have mountains of data generated, mole heights of insights, but for some, the challenges remains, what to do with the data. So a lot of companies are generating a lot of data, but it's it's often the case where they don't need that much data to actually, implement whatever they need in order to, achieve what they want to achieve. Uh, so this also has to do with the fact that a lot of the data processing and analytics is done in-house. So because of IP or various other uh, issues that they do not necessarily partner with a lot of IoT-specific companies. So this is a challenge that needs to be addressed for these large-scale enterprise digitizers. And then we have legacy investment. Even though they have large-scale IoT implementation, that's often done on legacy equipment, and so if they're able to actually upgrade to more intelligent equipment that has more built-in solutions, which can then be networked with their existing IoT level solutions, they might be able to improve the accuracy of their predictive analytics and also be able to do it in a simpler manner. So for these companies, key focus areas tend to be enterprise rollout of initiatives. So it is about extending whatever they roll out across various locations that they have, and then use of machines to analyze data and augment human intelligence. So often is the case where a lot of data is generated and they're using analytics to sort of improve their predictive maintenance. So it's not just to improve predictive maintenance, but also to improve the human factor here, where in a lot of cases, the decision is still left to the plant operator, and so, how do we help the human get more intelligent, not just the machine? So that tends to be a focus area for the enterprise digitizers. And then we have progressive movements to full field analytics. So despite having mountains of data, analytic implementation might only be restricted to some machines or to some plants, whereas the other plants might not be implementing them on a wholesome basis. So, they are progressively upscaling to full field analytics, where they can see the benefits of IoT across the entire spectrum of machines that they have. And then, if we look at a customer success story, so we have two customer success stories over here. We have one for pneumatics and one for hydraulics. In the case of pneumatics, so the operational challenges that the end user faced was, number one, the high energy costs because of poor compressor operation, overpressurization, and air leaks. It's often the case that compressors are actually sized much larger than they need to be, purely based on the fact that a lot of end users are not really entirely aware of pneumatic system design, and so they go with the highest compressor that they, highest powered compressor that they can. And then we have high maintenance costs. So insufficient air storage, improper use of compressed air, repeated shutdowns. These are all some of the operational challenges that were cited by the end user. And also facility managers found that compressed air systems are often unreliable. So, in order to address this, they needed information and they didn't have at the time. And so they turned to an IoT partner in order to solve some of these challenges. So the way it was implemented was there was an IoT platform that provided visualization of key data. So wireless sensors were installed across the plant on various equipment, and then this was connected to a cloud-based condition monitoring system, and the entire fluid power system was connected to an IoT gateway to enable analytics and storage and the whole IoT implementation. So the results that was actually witnessed by the end user, you had increased efficiency and decreased downtime. So this this was a direct result of the fact that they were able to identify air leaks, they were able to improve compressor operation, they were able to, with the data, understand when the compressor did not need to run in order to vastly help reduce energy consumption. And then it also augmented the manufacturer's revenue because they were able to charge a recurring fee for additional services, and the subscription-based fee also reduced the end-user burden, therefore acting as a win-win scenario. And it also differentiated the manufacturer from their competitors in the saturated market due to the value-added wireless IoT solutions. So this was a service-driven success story. And then if you look at the next one, which is the hydraulics customer success story, this is more of a product-driven success story where the end user the biggest operating challenge for them was the fact that because they had very challenging inspection time. They had to do it under challenging conditions early in the morning, so they were not able to properly assess their hydraulic hoses for damage or failure. This often resulted in their hoses being replaced much earlier, or they're not being replaced on time. And so that was, both the cases were detrimental, and then hydraulic fluid leakage was unacceptable because it could result in the shutdown of the facility, causing monetary and reputation damage. So in this case, a diagnostic unit which provided actionable data was used. So sensors were used to continuously monitor these hose conditions, and then the diagnostic unit helped generate alerts whenever the hose damage was identified based on a number of parameters that were constantly being monitored. So this resulted in a data-driven replacement of hydraulic hoses rather than having it manually inspected. So this eliminated unwanted hydraulic hose replacements. It augmented the manufacturer's revenue because of the significant value that the end user acquired from this, and which reduced their total cost of ownership, and then which resulted in more implementation across various other facilities. And it also provided an IoT solution that was cost effective but added great customer value, thereby helping the manufacturer then propagate this solution to other end users. And then we have our final poll question for the day. Over to you, Anna.
Thank you, Varun. Our last poll question: what are the digital services that are of paramount importance to your organization? So we'll leave this open, and back to Varun to go over the key takeaways, conclusions.
Yes. So we come to near the end of the webinar where we are looking at so what Frost & Sullivan believes is the last word and the conclusion for this webinar. So fluid power industry, we know, is going to grow because of the proliferation of these IoT solutions. We've talked about a couple of customer success stories. These are just a couple. There are so many other customer stories that are being that are coming out every day with more implementation. And so this is going to definitely give a boost to the fluid power industry itself, particularly in the case of brownfield IoT implementation. And then we have the digital ecosystem, which is going to develop because all the players in the value chain are going to be contributing to this cause. So we have manufacturers bringing out more digital products. We have OEMs, so we have end users who are actually requesting more IoT solutions, more digital solutions, because they want to be able to improve their manufacturing processes, reduce their operating costs, and improve their bottom line. So this is eventually going to cause the OEMs to then seek out more of the digital solutions and push them onto the market. And then related to that, we're going to see upskilling of the workforce because of the skill shortage that exists. Some of the existing workforce is being upskilled to deal with the more digital solutions that are being pushed out, and then eventually with more fluid power programs that are being taken by various governments, we are expecting more skilled workers to join the fluid power industry in the next 5 to 6 years. And then we also see new business models are going to emerge because predictive analytics is going to gain popularity. This is no longer going to just be a hardware-driven industry where the hardware component costs are constantly coming down because they're commoditized products, because they're competing with other manufacturers, and because sometimes there tends to be bulk equipment purchases. People are negotiating hard to reduce the price. Particularly when sometimes you have industries that go through cyclical downturns like oil and gas. But then this is where predictive analytics, this is where the software side of things is going to have a bigger opportunity in order to create a recurring revenue stream. And Frost & Sullivan is where we can help with this whole digital transformation, is to act as the bridge between the OEMs, between the manufacturers, between the end users, because we speak to all of them, because we are interacting with all of them. We get this information and we are there to help whoever wants to grow. And then, that brings us to the end of the webinar. And over to you, Anna.
Thank you, Varun. Okay, so we have about 5 minutes left, so I'm going to go over the poll results quickly here. And so our first poll question, we asked, what stage is your organization in with respect to the IoT implementation? 100% of our audience indicated implemented recently. Our second poll question, we asked about the biggest challenges you face in developing and delivering digital solutions. So we have, it's a split. 40% of our audience indicate cost prohibitive and customer reluctance, and then 20% indicate there's resource constraints, there's a skill shortage. So, and then our last poll question, we asked, what are the digital services that are of paramount importance to your organization? And 100% of our audience indicated predictive maintenance. So those are the results. I had just one question here from our audience regarding slides and recording. So the on-demand session, for those that have just joined us, the on-demand session will be available shortly after we finished. At that time, the recording is available along with the slides inside the recording. So at this point, I don't see any questions here, so I'm going to end the session. I just want to thank everyone for joining us today. And if there is any further queries, anything for Varun, I will post his contact details on the screen at this time. Please get in contact with him by phone or email. And thank you again, and enjoy the rest of your day.